Greetings students, once again welcome to another video from iCampSA, another lesson on trigonometry, a past paper question we are doing today from November 2016. Let's get into it. Okay, so for question 4.1, a right angle triangle has sides A, B and C and their angle theta as shown below. Write the following in terms of A, B and C. Okay, so we have to write there what you call this thing, the trigonometric ratios in terms of A, B and C in terms of the sides. Okay, so this one I think it's pretty straightforward. 4.1.1, A for A we have to determine cos theta. What is the ratio of cos theta? Cos theta is just simply, whenever you are doing trigonometry, just remember your mnemonic of SOHCAHTOA. So we know that cos is adjacent over hypotenuse, and here is our theta. The side next to theta is what? Is B. The hypotenuse is C. So cos theta is equal to B over C. It's equal to B over C. And then for B, tan theta, TOA is opposite over adjacent. Which side is opposite to theta? Is A, is side A, and the side that is adjacent to theta is B. So we're gonna have A over B. Okay, we're gonna have A over B. And then for C we have sine 90 minus theta. Which angle is 90 minus theta? Remember, we are in a right angle triangle, and the sum of the angles in a right angle triangle is 180 degrees. So here in this right angle triangle we have theta, we already have 90 degrees. So that means the other remaining angle will be what? Will be 90 minus will be 90 minus theta. It's gonna be 90 minus theta, and the reason was it's sum of the angles in a triangle. That's the angle we are referring to when we are saying 90 minus theta. For those of you, if you don't understand, the sum of angles in a triangle is equal to 180 degrees. Let's come here. We have angle 90 degrees there, 90 degrees plus angle theta. Okay, plus that angle, that unknown angle here, let's call it what? Let's call it alpha, plus alpha is equal to 180 degrees. Sum of angles in a triangle. Let's determine what alpha is. Alpha is equal to, take everything to the other side, 180 minus 90 is gonna be 90 degrees minus theta, it's just minus theta. And as you can see that alpha will be 90 minus theta. So let's come here, sine alpha is equal to 90 minus theta. Okay, so we have to determine the ratio of sine alpha, sine 90 minus theta. Look at me saying sine alpha. The ratio of sine is what? Is opposite over hypotenuse. What side is opposite to the angle of 90 minus theta? Is B. Hypotenuse is theta C. So we're gonna have B over C. We're gonna have B over C. If it's okay, for 4.1.2, if it is given that A is equal to 5, theta is equal to 50 degrees, calculate the numerical value of B. We are given that A is equal to 5 and theta is equal to B. Calculate the numerical value of B. Now that is pretty simple, because we have to just look at the ratios that we have just determined on the previous step and see which one is A, B and theta, which one is A, theta and B. And when we come here, we see in turn we have theta, we have B, we have A. So we can use that to determine the value of B. So we say tan theta, what is the value of theta now? Is 50 degrees. Tan 50 degrees is equal to A. We have told that A is what? Is 5 over B. We just have to solve for B at this point. B is equal to 5 over tan 50 degrees, and therefore B is equal to, now we punch this in a calculator. Oh, in fact we can just do it like this. Yeah, and say b is equal to 5 over tan 50, which gives us 4.2 units. 2 units. Okay, that's the value of b. Then let's go ahead. That was 4.1.2. Okay, and then next we have 4.2. We are given that angle A is equal to 38.2 degrees and angle B is equal to 146.4 degrees. For 4.2, we have to calculate the value of 2 cosec A plus 3 plus cos 3B. So we say we have to determine the value of 2 cosec A plus cos 3B. Okay, before we substitute the values of A and B, what do we have to do? Let's change the reciprocal to the one we are used to, which is, what's the reciprocal of cosec? Is sine. So we have 2 multiplied by 1 over sine A plus cos 3b plus cos 3b. That's the first step. Let's now substitute the values of A and B. So we're gonna have 2 over sine A. What is the value of A? A is 38.2 degrees. 38.2 degrees plus cos into 3 multiplied by B. What is B? 146.4. 146.4 degrees. So this is gonna be 2 over sine 38.2 plus cos of 3 multiplied by 146.4, and then we have 3.42. That is the value of this expression for a given angles. And then next, simplify fully without the use of a calculator. So once they tell you to simplify without the use of a calculator, you simply know that you have to use special angles. Okay, special angles 4.3. For those of you who haven't memorized the special angles, let me bring some for you. I'll bring some special angles for you. Where is the triangles that helps us when dealing with the special angles? There we have copy. There you have it. Yeah. So I have multiple videos explaining how do we construct these triangles for those of you who don't understand, but yes, or we haven't memorized the special angles. So we have, what are we given there? It's 4.3 sine 45 multiplied by tan squared 60, sine 45 degrees multiplied by tan squared 60 degrees divided by cos 45 degrees. This is equal to, what is sine 45? Sine 45 is opposite over the hypotenuse, so it's 1 over, we come here into this triangle that has 45 degrees angle, opposite over hypotenuse, that would be 1 over root 2. So we're gonna have 1 over root 2 multiplied by tan 60. What is tan 60? Tan 60 is opposite over adjacent, so this is the opposite side, which is root 3 over adjacent, which is 1. So it's just gonna have root 3 squared divided by cos 45. Cos 45 is what? Is adjacent over hypotenuse. So once again we have 1 over root 2. So here we're gonna have 1 over root 2. Okay, and therefore we're gonna have what? we see you have a 1 over root 2 on the numerator and a 1 over root 2 on the denominator. So this and this would cancel. We will be left with root 3 squared, of which is equal to 3. Root 3 squared is equal to 3, and that will be your answer for 4.3. 4.3. And then next, given that 4.4, let me copy this. Given what we are given there, let's see what we have to determine. Given 5 cos beta minus 3 is equal to 0. 0 and beta is found between 0 and 90 degrees. If alpha plus beta is equal to 90 degrees and alpha is also found between 0 and 90 degrees, calculate the value of cos alpha. So here what you need to understand is that we are dealing with complementary angles. If two angles add up to 90 degrees, they are complementary angles. But before we even get there, let's make a use of a sketch to help us with this question. So we are given that 5 cos beta minus 3 is equal to 0, and beta is found in the first quadrant between 0 and 90 degrees. Let's start by rearranging this. We're gonna have 5 cos beta, take the 3 to the other side, we have positive 3, divide by 5 on both sides. Therefore cos beta is equal to 3 over 5. Cos beta is equal to 3 over 5. Okay, and then next from there, let's draw our sketch and see where our terminal arm will be found for this question. Okay, so first thing first, we have cos beta there being positive. Okay, and beta is found in what is this? Is found in the first quadrant. So beta is, we have been told it will be in this quadrant. So that definitely just tells us that the terminal arm will be there. So yeah, it should be here because beta is found between 0 and 90 degrees. Remember that our Cartesian plane, we have 0, 90 degrees, 180 degrees, 270 degrees, and 360 here, 360 degrees. Okay, so actually rearranging that cos beta into 3 over 5 helped us to see that now, remember that the ratio of cos beta, of course, is what is adjacent over hypotenuse. Here we'll have our beta, that is your beta, angle beta, and the hypotenuse side is what is 5. The adjacent side is what is 3. Adjacent side, which is the value of x. Yes, it's the value of x. Okay, what unknown do we have here now? We have the y unknown, the other side of this right angle triangle that we have here, and we can use what? Pythagoras theorem to determine that unknown. So y squared is equal to r squared minus x squared. What is r squared? R squared is 5. What is r? R is 5 squared minus x, which is 3 squared. Therefore y squared is equal to 5 squared is 25 minus 3 squared, which is 9. That will be 16. We introduce a square roots on both sides. Y is equal to 4. Y is equal to 4. Okay, now we have the value of y. Okay, once we are here, we know that alpha plus beta, alpha will essentially be the angle here. Alpha plus beta are equal to 90 degrees, or if you like, we can say that alpha is the angle here. If we look at the right angle triangle, yeah, it's the same thing basically. Alpha is that also angle. In fact, let's just use that one, it will far more simple, but it's also this angle here, since they are equal to 90 degrees, you know, because it will go from 0 to 90 degrees. Here the angle here is 90 degrees. So if we know that alpha plus beta is 90 degrees and beta is this angle here, that means alpha is this angle here. But look at the alternating angles also again, so it's the same thing. So we have that let's just focus on this one here on the triangle. We have to determine the value of cot alpha. Cot alpha. For cot alpha, what is cot alpha? Cot alpha is, or the ratio of cot. Remember, cot is the reciprocal of tan. So cot is equal to 1 over tan alpha. 1 over tan alpha. What is the ratio of tan? Is opposite over adjacent. So this is 1 over, what is the opposite side? Opposite side, the side that is opposite to the angle alpha, is 3 divided by the adjacent side. Which side is adjacent to alpha? Is 4. So this is equal to 1 over 3 over 4. Therefore it's gonna be 4 over 3. And that is the value of cot alpha for 4.4. Okay, it was the last question in question 4. Hopefully it made sense. Let's go ahead and do question number 5. So for question number 5, in the sketch below, M and P is drawn having a right angle N, and MN is equal to 15 units. A is the midpoint of PN. AMN is equal to 21 degrees. So if A is the midpoint of PN, it has also been just demonstrated. So AN is equal to AP. Okay, and then we have to determine the value of AN. Let's just focus initially on the triangle MAN, because we're looking for that side. Which side? We're looking for AN, and we have this angle 21 degrees and the adjacent side there, which is 15 degrees. We are looking for the opposite side. So we're looking for the opposite side. We have an adjacent side and the angle. So adjacent, which trigonometric ratio includes the opposite and the adjacent side, that is the tan trigonometric ratio. So tan 21 degrees is equal to, opposite is what? Is AN over the adjacent side, which is 15. So AN is equal to 15 tan 21 degrees. Therefore AN, punch this in your calculator, 15 tan 21 degrees, it's 5.76. AN is 5.76 units. That is the value of AN, 5.76 units. And I told you that AN, since A is the midpoint, is also equal to AP, 5.76. Therefore when you add those two, they will give you the value of that side. In fact, PN, let me just do it like this, times 2 is gonna be equal to 11.52. Okay, and then next we are asked to calculate the angle PMN. There is now bigger angle here. Okay, and what do we have? We have this side, which is 15, and we have this side, the complete side there, or the entire side here, PN, which is equal to 11.52. So we have the side that is opposite to angle M, and we have the side that is adjacent. So once again, what do we have to use? We have to use the tangent. We have to use the tangent to determine angle PMN. So we say tan PMN is equal to, what's the opposite side? Side PN is 11.52 divided by adjacent side is what? Is 15. So for PMN is equal to tan inverse 11.52 divided by 15, and then PMN is equal to, punch this in your calculator, 11.52 divided by 15, that gives us 37.52 degrees. That is the angle MN. Okay, and then we're asked to calculate the length of MP now. Length of MP. What is MP? MP is the hypotenuse side of this triangle. So you can calculate the angle the side MP by using the Pythagoras theorem, or you can use the trigonometric ratios. For 5.1.3, let's use the Pythagoras theorem. So for 5.1.3, MP squared is equal to, what's the other side? Is equal to 11.52 squared. 11.52 squared plus 15 squared. Plus 15 squared. This is equal to what is 11.52 squared is 132. 32.7104 plus 15 squared, which is 225. Okay, and then you add to those, you get 357.7104, and this is MP squared. At this point, you introduce the square root. Therefore MP is equal to the square root of 357.710. the answer is 18.91 units. That's the length of MP, 18.91 units. And that is the answer for 5.1.3. okay, for 5.2, calculate theta. Okay, if we have those conditions, first thing first, let's put it here. Let's drop, take it up, drop. Okay, so we have to calculate theta if 2 sine theta plus 15 is equal to 1.462, and theta is found between 0 and 90 degrees. Okay, so we have to calculate theta here. Basically, we have to solve for theta. So we have 2 sine theta plus 15 degrees is equal to 1.462. Solving for theta, first step, let's divide by 2 on both sides. We will be left with sine theta plus 15 degrees is equal to 1.462 divided by 2. Okay, that is 731 over 1000. Okay, theta, let's take sine to the other side. Theta plus 15 is equal to sine inverse of 731 over 1000. Okay, and then theta, we punch that in the calculator. You punch that in the calculator. You get what? You get 46.97 degrees. You take 15 to the other side. We're gonna have to separate the negative 15, and therefore theta is equal to minus 15 is equal to 31.10 degrees. That should be your theta. Okay, 5.2. I think that was the last one in question 5. I hope you guys understood what are we doing here and how we go about solving such questions. Let's move on to question 6. Question 6 is trigonometric functions. Trigonometric functions. So the graphs of f at x is equal to a sine x, a sine x. That a there tells us, it gives us the vertical stretch. And g at x is equal to cos x plus 1. Okay, so function of g, that's the cosine. Function of f, that's the sine function. For x is the element of 0 to 360 degrees. As sketched below. Write down the value of a. A told you that is the vertical stretch from the baseline to the maximum. So it's from 0 there towards to the maximum point of which is 2. Therefore we're gonna have a being 2 sine. This is gonna be 2, not 2 sine 2. 6.1 a is equal to 2. Okay, and then write down the period of f, how long it takes for the sine function to complete one cycle. We know that this is a complete cycle for a sine function, so go from 0 to 360 degrees. The period is what is period is equal to 360 degrees. And then write down the range of g. Let's come to the function of g. You see here the maximum point is 2 and the minimum point is 0. So the function of g exists between those 2 points, between those two maximum of 0 and 2. Therefore the range of g for 6.3 is going to be y is the element from 0 to positive 2 square brackets. Okay, and then for 6.4, for which values of x in this domain will f at x multiplied by g at x be greater than 0 positive? So we're basically looking for those values of x whereby if we multiply these functions they give us a positive outcome. So they have to be both positives. So we're looking at the values of x where both functions are above the x-axis, or where both functions are below the x-axis. And then let's come here from 0 to 180 degrees. You see both functions, they are above the what you call this thing, the zero line. They are both positive. They are above here, the 0 line. They're above 0, so they are both positive. A positive and a positive will give a positive. And then when you get to 180, the f function, it goes below 0. So a negative multiply a positive will be a negative, so it's no longer gonna work. So, and also where they are both 0, or where one function is 0, it's not gonna work, because that would give us an answer that is equal to 0, and we are only interested in values that are greater than 0. So it's basically the values of x are greater than 0 but less than 180 degrees. So what I'm saying is 6.4 is where x is greater than 0 degrees but less than 180 degrees. Those are the values of x that will satisfy that condition. 6.5, the graph of g is reflected about the x-axis and then shifted 2 units upwards to obtain the graph of h. Write down the equation of h. So for 6.5, we're told that the equation of h at x will be equal to the graph of g negative, because to reflect we have to introduce a negative sign. This is how we reflect a graph about the x-axis, and then shift 2 units upward plus 2. Okay, what is the graph of g? H at x, let's come here, minus, what is the graph of g? Cos x plus 1 into cos x plus 1 plus 2. Therefore h at x is equal to negative cos x minus 1 plus 2. Therefore h at x is equal to negative cos x minus 1 plus 2 will be plus 1, and that will be the new equation for the h function. That is how you go about solving that one. Okay, that was our 6.5, of which is the last question. I hope you guys learned something from today's video. Until we meet again, I wish you all good luck and good studying.